guys. I am Jeff McDowell. I'm a program manager working on security, compliance, and access policies. This is Matt Swann. He's our chief security architect. Matt's going to talk to you about kind of how we secure the OneDrive and SharePoint service behind the scenes. I'm going to come back a little bit later to talk about some of the tools we give you to secure your organization and your users. You want to take it away, Matt?
Yeah, thanks, Jeff.
All right.
Guys, thanks for joining us this afternoon on the last day of the conference. I'm here to take you behind the scenes and let you see all the work that we do, both ahead of time and then on a day-by-day basis, to keep your data secure. So like Jeff mentioned, my role as Chief Security Architect is to make OneDrive and SharePoint the safest place for your data. And I need to make that true whether you are a small company, a small business of maybe 3 to 5 people, or whether you are a large business like Lockheed Martin with a multi-million-dollar security practice, where you're publishing papers and advancing the state-of-the-art in network security for the field as a whole. This still needs to be the safest place for your data. And so our focus is on you and on maintaining your trust. And because we do our work with integrity, I'm pleased to be here and be transparent about how we treat your data. So OneDrive and SharePoint is a cloud-scale service, of course, as you know. These are hundreds of thousands of servers, petabytes of cloud storage under our care, split across many Active Directory domains, or in many cases, none at all. And this scale creates unique challenges for us, because the typical ways that we would administer a cloud service or an Active Directory network or do security patching and anti-malware signature updates, these techniques no longer scale. And so my engineering team's job is to build cloud-scale security systems that use this scale to our advantage rather than letting it be a hindrance. So often when we talk about security, we talk about defense in depth, right? The notion that there's many, many layers that must be bypassed by an adversary in order for him or her to get access to your data in our cloud. So you're probably familiar with this slide, right? We talk first about physical security, about how our data centers are locked down only to people who can go through the biometric screening to get in the door and to have access to enter a locked room, have the key for those locked cages where the physical hardware is. We talk about how we isolate the networks that contain your data, about how there's no trust between those networks and other networks at Microsoft, no trust between that and our corporate network, about how even our production environments are network isolated from one another for better fault and security tolerance. We talk about how we secure your content with things like encryption at rest and in transit, with per-file encryption, where each file gets a unique key, how our drives are BitLocker encrypted, about how we do HA and DR across multiple regions so that we have a disaster recovery strategy. Of course, we want to make sure that our engineers are trained and write secure code in the application itself, how we have great incident response processes for defects that are found there, how we encourage researchers to help us find security vulnerabilities by paying them a bug bounty, and how we control access by our engineers using two-factor authentication, just-in-time access so that no one has standing access to content, and features like customer lockbox, where in fact no engineer has access to your content without first asking permission. But what I want to cover today is defense in action. And this is 5 things that we do every single day to keep your data secure. Not just the things that we've designed and implemented, but the ongoing processes that are in play today in our data centers. And as I walk through these, I want you to think about the IT challenges or successes or the IT mechanisms that you have working in your organization. Compare those to how we administer our service, and think about where there are gaps maybe that you want to ask about, where there are advantages to moving to the cloud because there are some things maybe that we're at a scale or a maturity level greater than where you're at right now. We're just happy to be transparent about how we keep your data secure. So the first thing I'm going to talk about is how we keep a secure baseline across a fleet of over 300,000 machines. Right, we've got to make sure that every one of those machines is trustworthy and meets our requirements for being able to handle your data. But next, I need to know what's happening on each one of those machines. And so I'll talk about how we collect petabytes of telemetry from those servers and from our Azure resources, like Azure SQL and Azure Blob Storage. But I need to do something with that telemetry. So I'll talk about how we utilize it to detect threats, about how we build incident response tooling that scales to the size of our cloud, the size of our Azure infrastructure, so that when we do detect a threat, the scale does not become a hindrance to us. It's not a disadvantage. And finally, I'll share how we use red team engagements to validate our assumptions and make sure that we are exercised and ready to play against a real adversary if one was present in our service. Does that sound good? All right. So let's start by talking about secure baseline. We believe in something called attestation-based security. And that means that each VM, each physical machine in our network needs to constantly prove that it's in a healthy state. And if we can't measure it, if that machine can't prove that it's in a healthy state, then we're not going to trust it. We're going to tear it down, pave it, reimage it, put it back into service. But at the scale at which we operate, it turns out that counting all of these machines and asking them about their state is a surprisingly challenging problem. Because at any given time, hundreds or thousands of those machines might be being provisioned or paved or reimaged. Maybe they just received patches and they're rebooting. And so if I just simply scan across all of them, maybe I run remote PowerShell and touch each one, I'm going to miss some. But the hard part is I won't know which ones I missed, right? So that model didn't work for us. So we turned it on its head, and we decided we're going to have each machine push its state to us. And then from there, we can aggregate it, store it in a search index, and do queries on it. So let me show you how this works. So I've got 4 machines here. One of them's unhealthy, and I've deployed a little agent that we call the inventory agent to each machine. And I'm going to push down questions from a cloud service that each of these machines is going to answer every hour. And these are questions like, is anti-malware running on your machine? How old are your anti-malware signatures? Do you have our required security and telemetry services? Are critical registry keys set the way that we expect them to? And those answers then get pushed up into another Azure cloud service, indexed in Redis, and then we expose those via a REST API. And that data is incredibly useful first for our engineers, because engineers who own systems in the environment can query, like, what's the health of my system? Is it working the way that I expect it to? Maybe I just received a notification of a patch or a vulnerability, and I need to find which machines have a given registry key set. Right? If you remember when WannaCry happened, knowing which machines had SMB enabled was incredibly important. Well, this is how we solved that problem and knew which machines needed patching and saw that machines were receiving patches on a cadence that we expected. Now this data, because it's in a Power BI or REST interface, I can do charting and graphing on it. I can build reports for my leaders and for other engineers in the system. But my favorite thing that we can do is we can use this data to auto-heal machines that are unhealthy. So every couple of hours, we pull the latest data from the system, and we reach out and we pave or re-image the physical and virtual machines that told us that it was unhealthy. So if your machines are missing anti-malware patches or anti-malware is not running, that machine is gone. It's no longer considered trustworthy. But you might have observed I have a gap here, right? What if I have a machine in the fleet that's unhealthy, and it's so unhealthy that our inventory agent isn't even running on it? So we thought about that too, and we taught our machines to scan their neighbors, to find machines that are online, on the network, but not listening on a port that the inventory agent exposes. And when that's the case, I can do the same thing. I can auto-heal those machines and bring them back up to compliance. And so this achieves a couple of things for me. First, it gives me confidence, right? I know my known knowns, the machines that are checking in, and I know I have known unknowns, right? Machines that are online but aren't giving me status about their inventory state. It gives me agility, right? No matter how large my fleet grows, if it grows from 300,000 to 1 million in the next 6 months, I will still be able to ask questions and get answers every hour, right? It doesn't slow down as I add machines. And it gives me improved operational rigor. It turns out everyone wants to be accountable to have a properly functioning service, whether that's security or performance or telemetry. But if you can't measure it, you can't enforce accountability. People don't know whether their service is running or not. So when we built this, it was like shining a flashlight into places that we didn't have visibility before. And it really improved things like performance and reliability and availability for the service that you all experience, because from the ground up, we were able to keep things healthy and secure. So on that secure baseline, the next thing we focused on was telemetry. We need to know what's happening on each one of these machines if we're going to have any chance of detecting an intrusion. So we collect Windows security event logs and other data from the machine at massive scale. Right? We pull 20 terabytes a day from over 300,000 machines in our fleet. That includes all of the internal activity. It's not customer activity. So things like process starts on these machines, Microsoft engineers logging in to do break-fix activity, deployment, upgrade, patching. And we retain all of this data for a minimum of 1 year. So you can kind of do the math, 20 terabytes a day times 365 days a year. That's well over a petabyte. And we make use of this data both for batch processing. So maybe we'll look back at the last 30 days and say, what's normal versus unusual about today's activity relative to the history in the past? We also do real-time queries over this, either as events are being sent through our system or on demand as engineers have questions and need to understand why something is working the way that it does. But telemetry at the scale actually generates challenges for us, right? It's not all roses. One of those challenges is, well, how do I make use of it to detect an intrusion? We started out thinking, well, we'll just look for bad things, right? There must be some event that says that, malicious activity is happening. So we started to look at failed logons, for example, and it turned out that that didn't really tell us whether an intruder was present or not. So our next attempt was, we'll just look at all the good things and pull those out, filter those out, and whatever's left over must be bad. But it turns out that humans are doing break-fix activities all the time. The environment is constantly changing and being upgraded, and so ignoring all the good things wouldn't really work for us. And we also saw that our red team would abuse legitimate access in order to get their job done. So if we ignore everything good, we run the risk of ignoring our red team activity as well. So then we thought, well, let's be super sophisticated. We'll use machine learning to look for anomalies, but we ran into something called concept drift. So our data scientists would look for anomalous behavior. They'd train a Markov chain model to know what the sequence of normal events is. And then every couple of weeks, the graph of anomalies would show this big spike, right? This big introduction of anomalies. And at first we're like, oh gosh, like something really bad has happened. Maybe there's an intruder present. We better dig into this. But what we learned was that this is just normal patching and upgrade and deployment activity. We had trained the machine learning model on what normal looked like 2 weeks ago. And then today, we changed how the environment works. We're constantly changing how the environment works as we improve and scale out. And then the machine learning model correctly raises its hand and says, hey, things look different. And so this wasn't really being effective for us. So we were still struggling to make use of this 20 terabytes a day. So we stepped back and we said, instead of taking a data-first approach, I have data, how can I make use of it? We decided to take a threat-first approach and said, well, what is it that I'm actually trying to protect, right? I have the assets inside my data center. I have assets outside my data center that are involved in maybe how my engineers get access or how they administer the data center. Who are the threats to those assets? And here we worked with Microsoft's Threat Intelligence Center, pulled in external breach reports and industry reports from threat intel providers. We worked with our red team to understand how they get their job done when they break into our data center. And then we said, well, okay, these threats, how do they get their job done? What tools do they use? What evidence would they leave behind? And here, we're following in the steps of Dr. Edmond Lacard. So he was the early 20th century father of modern forensic science. And his contribution to that field was the notion that every contact leaves a trace. So every contact between an adversary and the victim, or an adversary and the room where the crime occurred. So as an adversary or an attacker, if I walk into a hotel room, commit a crime, and leave, some of the fibers from the floor in that hotel room are going to be left on me, and some fibers from my coat or my jeans are going to be left behind in that hotel room. And so it's the job of a forensic scientist to match those two pieces of evidence up to identify the perpetrator. So we took the same approach. We said, well, if an adversary is present in my environment, how would they work, and what evidence would they leave behind? And we had already started with Windows security event logs, so we looked there first. We said, well, that's great. I can see process starts and logon events, but although that's necessary, it's not sufficient. Many of the things that an intruder would do, like send lots of data out of the environment, aren't captured by Windows built-in security auditing. So as we did more research, we were pleased to discover that Windows has built-in trace logging in a system called Event Tracing for Windows, or ETW. And this is built into the Windows kernel. This is actually how Windows engineers understand and diagnose how their own subsystems are working. So every memory allocation creates an event here. Every thread that's created, every network request that's received or sent, all goes through here, all generates trace logs that we can look at. So we realized this is going to be a gold mine if we can somehow keep up with the scale of every single event that's going to come out of the system. So what we did is we built a little agent, a security sensor that we deployed to every machine. And this agent implements a real-time pipeline that's consuming these events, filters, aggregates, does analytics on them, and then sends data back out to the security event log. And the security event log data goes into real-time systems for alerting, correlate it with other events, and then we store that for a year and use it for forensics and incident response as well. So this was really the key to unlocking our ability to see threats and detect them as they start operating in our data center, rather than looking back at security event logs after a red team operation and trying to piece back together what they did and how they got their job done. One of the amazing things that we're able to do, because we're running code that's looking at every network request when it happens, is we can do statistics on the fly to look for things like periodic network traffic. Now, when network traffic is periodic or beaconing out of our data center, that doesn't mean that it's malicious. But very often, malicious network traffic will share this characteristic or have this profile. And so by doing a little bit of math on each request as it comes in and keeping track of the quiet periods between the beginning of each request, we were able to distinguish between some types of malicious traffic and the long tail of benign traffic that happens in our environment. And so this gave us all the evidence that we wished that we had had when we started building intrusion detection years ago. Right? We know all the network activity that's coming in and going out of our environment. We know all the DNS lookups that are happening. Any requests that are made through the WinINet API, such as Internet Explorer or Edge, we can see every PowerShell method that gets executed. And we had this capability before PowerShell added its own logging, which was great. We can see WMI, which is often used for administrative tasks or for lateral movement from one machine to another. And then we can see even every thread that's created, who created it, from which process, into which process, and at what start address. So everything we wanted to know about what's happening in our environment is now exposed to us. But we couldn't just stop at Windows, because as we expand and grow our data center, our storage has moved to Windows Azure as well. And so, for example, our content databases are stored in SQL Azure. The document storage for your content, encrypted, stored in Azure storage, Azure Blob storage. And so our visibility needed to extend into those systems as well, because they are part of securing your content. But just like we had scale challenges learning how to deal with 350,000 machines at once, we also needed to learn how to scale to the magnitude of our Azure services. Because we don't add a new machine in our data center each time a new customer signs up. But each time a customer or a set of customers starts uploading more data, we have to scale all of our Azure resources. And so we have a whole different scale magnitude that we need to keep up with. And so we built another streaming pipeline that was geo-distributed and watches all of this activity in real time. Let me show you how it works. So when a customer interacts with SharePoint, say they upload a document, that goes into the content database, and the document contents go into Azure Blob encrypted. Each of those systems generates an audit event that gives me the IP address of the SharePoint backend machine that interacted with Azure. It gives me some details about the storage account that this data was stored in, what kind of operation it was it a read, a write, a delete? And then we have a system that's deployed in many regions all around the world that are crawling those audit logs, almost like a search crawler in real time. We parse those, run detections against them in real time, and then emit alerts and statistics and dashboards that our engineers can use to understand whether our Azure storage resources are being used in an appropriate manner or not. So the scale of this is mind-boggling, at least to me, right? We stood this up knowing that it was going to be large and fast, but didn't really grasp the fact that it was going to be 500,000 events every second. So if you think about the scale of time in 2 seconds, right? 1,000, 2 1,000. In 13 different regions around the world, we just processed, a billion events, or sorry, 1 million events. So it's a mind-boggling scale, and this thing runs, right? We scale it out, we let it run, and we don't have to maintain it every day. We just get data out of it that helps us understand how our environment is working. We do this in real time. So our target is to scan each event or each audit record as it comes through in less than an hour from the time that audit record was generated. And then it gives us tons of context as well. Context about how our data center works and how SharePoint Online and OneDrive is built is one of the secret weapons that we bring to bear against an adversary in our environment. Because we know how the system is supposed to work, we don't just have to look for anomalous activity. we can tightly define what good looks like in this case and say anything, a delete in our blob storage should never happen, right? We know how deletes work. They don't, we don't point at a customer document and say, delete you now. We let those expire out. And so the moment that I can see a delete, I can fire a paging alert to my engineers and jump in and start to understand what's happening. So on the basis of all of that telemetry about Azure and about Windows, how is it that we actually detect threats? So we bring a couple of detection techniques to bear here. The first one is what we call oracle-based detections. And this is where I can nicely define what is appropriate or what's inappropriate. And then for each event that goes through the system, I can apply that detection to it, that logic, and say, this is good, I'll ignore it. This is bad, I want to alert on it. There aren't many detections that you can write this way, but in some systems and in some contexts, this works extremely well for us. In other cases, we write threshold-based detections. So if you were to imagine looking at the amount of data that's transferred out of our data center to a given destination, when that reaches a threshold and goes above it, I want to get an alert. I want to look at why so much data is leaving my environment. But I can't write an oracle-based detection to say these are all of the destinations that should receive traffic at exactly this many bytes per day or per hour. Right? So I need to do some statistics and see what normal looks like here. And then that leads us back into purely statistical detections, where I don't know what normal looks like per se for the registry keys that are present in our data center across every machine, or maybe the processes even that are starting up and their parent-child relationships. But what I do know is that across 350,000 machines, they should all be identical. And so I can use that to self-baseline what normal looks like, and then look for anything that steps outside of that and alert on it. And then finally, some kinds of investigations are expensive to perform. And so we write trigger-based detections that when an event happens, runs an expensive workflow to go maybe take a process memory snapshot, post-process that memory, and identify whether malware is present. Because of the CPU cost of that, I can't be doing that at all times on every machine. But when I see something that could indicate that malware was injected into a process, I can take action automatically. So out of this, almost 100 billion events a day, this generates about 100,000 detection results for my team to review. So the same engineers that build the system are embedded within SharePoint and OneDrive are also the same engineers who receive the alerts from the system and who look at the behavior of the system and the behavior of the environment using these tools every day. Again, we believe that the context that we have about what normal looks like and how our environment works, that's one of our secret weapons. And so this isn't a job that we hand off to a security operations center somewhere. This is our job. We are accountable for this. It's part of our relationship and the guarantee that we want to make to you. But 100,000 detection results feels like an awful lot, right? No human can process through all of that. So these come in different buckets. In the first bucket, we call them contextual results. And these are results that don't indicate that something malicious has happened, but we show them alongside other alerts or results to give context, to help our engineers know what else was happening at the time that this alert fired. Then we have behavioral alerts, kind of the next level down. These are alerts that if they just happen on their own randomly, I'm not real interested. But if they happen in conjunction with other behavioral or high fidelity alerts, then I bet they are probably related to an attack. So I want to kind of cluster these together. Atomic alerts are things that if they ever happen, I want to look at every single one of them. But sometimes they happen for benign reasons, so I can't page someone with a phone call each time I see them. And finally, we have alerts, right? This is the small set of things that generates an immediate phone call. And this is much more like the Oracle-based alerts or alerts detection types where when something matches, I know for a fact that it's bad. But I want to do more than just look at that small little section of real-time alerts. I actually want to take all of this into account so that I can have my engineers get paged even when there's a set of low-fidelity detections, behavioral or atomic detections that are happening on a machine or on a user. And so we use graph clustering to do that. So these are 3 examples of alerts from a red team engagement that happened a couple of years ago. And the first thing we did as we thought about how to make better use of these is we extracted out the components, the terms, the entities that these alerts have in them. So things like the process name, the username, the machine name. and what kind of detection had happened here, what kind of detection result it was. And then what we do is we represent these as a graph. This is a bipartite graph or a hypergraph, where we take each alert and we attach it to the entities that are contained inside of it. And we do that for all the alerts, and anytime two alerts have the same entity, we link those together by the entity that they have in common. And so by the time we're done, we have kind of a cluster of 3 alerts that are all linked together. And that context, right, seeing 3 alerts that have properties in common, means more to me as an engineer or as a security specialist than it would if I just had 3 disconnected detections that didn't have anything in common. And so we validated this hypothesis by doing a red team engagement. And what we found in the top left corner was that red team activity, actual attacker activity, links together very densely. And it's very obvious to us the difference between benign activity, right? Things like this purple dots where some behavior changed in the environment. There's only one kind of alert that's going off, but it's happening on many, many machines. It's very likely to just be emergent system behavior, versus different colors of dots linked together, where those are different detection types firing on machines and users that are in common. We found out that's very likely to be adversary activity that we want to go respond to. And so a couple of points here to recap. First, the 70 terabytes a day that we process using batch systems and real-time systems, this is incredibly important for us to be able to make use of the telemetry that we get. We don't just want to collect lots of telemetry, say that we have it, and put it in a data lake somewhere and then never look at it. Instead, we've spent years and years and many engineer hours figuring out how to most effectively use this to protect your data. We want to help our engineers make the best decision they can in the smallest amount of time from the moment that they get an alert. And so we've done lots of work on data analysis using things like graph clustering and different kinds of detections, right? Behavioral versus contextual, so that even with a small set of human analysts, we can scale up to hundreds of thousands of machines to protect our fleet. But what happens when we do detect something? Right? When we see that cluster of alerts that are all linked together and a paging alert goes off for our team to say, hey, there's a bunch of related activity going on that looks like it might be malicious, how do we scale that out? The thing to understand about incident response is that latency here is key. Right? If it takes me a long time to ask a question of my environment, get the results back, understand what those results mean, and then do the next thing, take the next action, then I'm going to be much slower than my adversary, who doesn't have to gather that kind of context, who's focused on a goal. So my ability to quickly iterate on asking questions and taking actions is what's going to allow me to succeed here. But again, like I have a big data problem, right? I have terabytes of data, something that's both an advantage and a disadvantage. So if the best that I can do is run event log queries, then I'm going to be kind of stuck. And likewise, if I have hundreds of thousands of machines and I need to take a remediation action, I can't run a script across all of those machines. I need to make it happen all at once. So let's figure out what kind of engineering we can do to meet this challenge. So we're big fans of deploying security agents to all of our machines, as you might have noticed throughout the talk. So we did the same thing here. And we said, you know, the first thing we need to do, we need to teach our machines how to identify something bad, right? So we're going to be able to push down indicators, maybe an IP address, a domain name, a process name, a username, something that represents or is associated with malicious activity that we're currently investigating. And that kind of inoculates each machine, right? So when it sees something malicious, it's going to detect it, send an alert to us and say, hey, remember that bad thing you told me I should watch out for? I see it. Here's the context in which I see it. I'm going to raise a paging alert so that my engineers know. Likewise, maybe I've found malware on a machine and I start to look inside of it. I understand, oh, it has words or characters or numbers like this inside of process memory when that malware is present. I want to scan my entire fleet, look through all process memory on every machine to uncover anywhere else that that malware might be running. And so we have a system for running workflows. And when those workflows match, they'll send a paging alert to our engineer. And we do that kind of offset across the whole fleet because we don't want to run an expensive operation across every front end at once. Right? That would impact availability and reliability. And so as stewards, both of your experience and your data and the security of your data, we work with the rest of the organization to make trade-offs like this, right? To build engineering systems that respect our ability to give you high performance queries, round trips, great web page availability. Once I've understood how an adversary got into my environment, once I've remediated that root cause, and I'm ready to actually kick him out, then I can flip all of our machines from response mode or investigation mode into remediation mode, right? So I've flipped red, and then once those machines realize that they're in remediation mode, they can pause or terminate processes that contain malware. And the nice thing is, if malware comes back, right, if that adversary is still present in the environment, these machines will, on demand, suspend those processes and give us another alert saying, hey, it looks like remediation wasn't complete, but don't worry, like we've paused this malware to give you more time to respond. What we found when we were working with our red team is that this forms a virtuous cycle for us. So maybe we found an IP address that's associated with our adversary. We add that signature to our service, that pushes out to each machine, and we get alerts from all the processes that are accessing this malicious IP address. Next, we run workflows to capture process memory from all of these malicious processes. And then we scan for those indicators. Maybe we find more processes that are malicious, that have the same malware in common, but are talking to different IP addresses. And so then we come back and we get more network indicators that we can put back into our system. Our red team was, I'm going to use the word unhappy about how quickly we were able to pivot from network to malware and process memory and back to network. Right? Our red team was really clever, and they said, you know, we know that the SharePoint team has good intrusion detection processes, but our hypothesis is that if we segregate our attacker infrastructure, and we have a set of IP addresses that we use in this part of the data center, and a set of IP addresses that we use in this part of the data center, the defenders will only find half of it. They'll clean it up, think they're done, and then declare victory. And all the while, like, the red team is still present in the other half of the data center. But because they didn't share IP addresses, but they did share tooling and malware, we were able to look across the whole environment and uncover the rest of their infrastructure rather than letting them hide and letting them win. So this was a really good win for us. And it was a really nice way to validate that our strategy works, right? Of not just having detections, not just having network visibility, but actually being able to look at both the memory from all of these hundreds of thousands of machines and the network traffic from these hundreds of thousands of machines. Because at the end of the day, the adversary has to be present in memory and has to do something useful over the network. So this gives us real-time visibility, right? If I add a signature, I get paging alerts in real time as soon as any activity matches that. The scope of this is super broad, right? So I can do investigation and remediation actions across the whole environment. I can do privileged operations without actually needing to log in, and it scales to the size of my fleet. And as we thought about this, we realized we can use this for preventative maintenance as well, right? When I get the bulletin that WannaCry version 2 happens, I can instrument my environment and say, if you ever see this process or this IP address or this username, suspend that process. Don't let it run. Send me an alert, but I will delegate some accountability to the agent running on the machine to be able to defend me in real time. I don't have to wait for an alert to happen to take those actions. Finally, our red team. I've talked a bunch about them. The red team is the key to our success, right? So the red team is a set of full-time engineers from an amazing set of backgrounds. We have people that are from 3-letter agencies in the government, people who are from financial services industries, people who won, cyber collegiate championships. Like, this is all they did in college was break in and defend things, and now they want to do it full-time as their career. These guys are deadly, right? Their job is to get into our environment by any means possible. Their job is to emulate a real adversary, right? Real adversaries, you don't get to give them a document that says you cannot send spear phishing mails, you can't use this kind of malware, stay out of this Active Directory domain. No, these guys, there's nothing off the limits for them. And so as a result, they help me exercise to find out whether I'm ready to play in the big leagues, right? If I can't simulate a real offensive engagement like this with the most talented adversary in the world, then how am I going to be confident that when a real adversary, right, a real apex nation-state adversary comes to attack your data in my service, that I'll be ready to detect and defend? And so that's why I think of the red team as being my most valuable partner in this whole exercise, because they show me the truth about myself. And if I'm going to do my work with integrity and then come and tell you that your data is secure in my platform, then I need to know what I'm good at and where my weaknesses are, where I need to improve. And that's what the red team does for me. So to recap, right, we talked about how we maintain a secure baseline, about how we prevent this scale of our environment from being a negative, a detractor. Talked about how we collect telemetry from it, how we use that telemetry to detect threats. When we detect threats, how we use incident response tooling that scales at the size of our fleet to be able to detect and remediate that adversary, and how the red team ties that all together by telling me whether I'm able to do this or not, letting me exercise that capability. But the great thing is, these same techniques that we've learned, these are things that you can also use to defend your organization, using the audit policies, the controls, the visibility that we give you through the Office 365 Admin Center. So, Jeff, you want to share that with us today?
Hey guys, yeah, before we turn things over for questions, because I know Matt went through a lot of stuff,
Yes.
I'm going to talk a little bit about how you can defend your own organization. Let me grab that from you. So for starters, Matt started off with secure baseline, and for our service, that really means kind of controlling the configuration and managing the state of all of our devices. When we talk about protecting your data and your organization, secure baseline means a couple different things. First of all, you still have to consider all of those devices. So the machines, the mobile phones, the other devices that your users use to create files, to upload files, to connect to our service. You need to make sure that those endpoints are in a healthy state. We would definitely recommend something like Windows Defender ATP for this. Whenever we're developing these detections and response procedures in the service, we work very, very closely with the Windows Defender folks so that they have similar detections in place there as well. Intune for managed devices, but there's actually a lot of different tools for this. If you have just Windows domain join machines, something like group policies or device state configuration. There's a lot of ways to push secure configuration down to your devices or to pull your devices to make sure they're in a healthy state. When it comes to being a business, though, that's got data in the cloud, there's another type of secure config to consider, which is policy, access policies and controls. Once your data is stored in SharePoint and OneDrive, where can your users send it? What type of external partners can documents go to? What about sensitive content? What happens after somebody downloads something onto a device maybe that you don't manage within your organization, or shares it with a specific partner? For that, we have a rich set of controls around conditional access and sharing. Each of these are kind of a talk in their own right, and in fact, there were some talks earlier in the week, both that did a deep dive into access policies and how you can connect those to this concept we have called labels, and also all the controls we give admins for external sharing and collaboration. These were earlier in the week, but I'm just going to leave them here as a reference because all these talks are being recorded, so if you're interested, you can check them out later online. Finally, I want to talk about something called the Microsoft Secure Score. If you're just getting started, you just kind of want to know what are our recommendations and what are the type of configurations that you should set up in your enterprise. You can go to a dashboard we have called the Secure Score in the Microsoft 365 Admin Center. You want to flip over to that? So I'm here looking at the Microsoft 365 Security Center, the new user experience. And if I go over to the Secure Score tab, I've got this scorecard, which is showing me how I'm currently doing against all of the different security recommendations that we make across the different M365 services. You can go down and get a concrete list of recommended actions, and each of these actions will be scored and given a weight based on how important we think they are. So right there at the top, you'll always see, I'll zoom back out. Right there at the top, you'll see worth 50 points. Set up multi-factor auth for your privileged admins, like for your global administrators. Always one of the #1 recommendations we get. But you can also kind of review through these. If you go then follow those suggestions and set up the policy. The secure scorecard will pick that up and give you credit, and you'll see your score go up. Or you could, review and decide these aren't right for you and dismiss them. But it's just a great place to go to just see all the different sort of configurations that we recommend that you at least think about. Next, I want to mention telemetry. In Office 365, we have this unified audit log capability. So I'm here looking at the classic admin center for O365 security and compliance right now. And this gives you a view across SharePoint, Exchange, Teams, Yammer, all the different Office 365 services, thousands of different event types. If I want to know if one of my admins is changing security or sharing policy in my organization, who's deleting sensitive files, I can set up a query to look for things like who is creating anonymous sharing links and sharing files outside of my organization. So let me go look for that. Yeah, so who's creating an anonymous link, meaning it's a unsecured link that can be passed around. I'll run a request on that real quick to see over the last few days who has done this activity. That's going to do a search. When it comes back, it's going to show me a bunch of different information: what IP address those requests were made from, when they were made, who's doing the sharing. If I want to see if a particular user suddenly has like a spike in all of a sudden sending a bunch of documents outside of my org, and even which documents being shared, if I want to look and review for particular sensitive documents. So this kind of gives you the capability to pull things together and query across all the different things happening in Office 365. By default, we keep these events for 30 days, but we also make them available to you by way of an API called the Management Activity API. If you want to pull these down and keep them for longer, if you already have a security detection and monitoring solution on premises and you want to pull these down and feed them into that, you can do that as well. In terms of alerting, in the new Microsoft Security Center, we have this alerting experience that actually pulls together alerts from a bunch of different sources. So Office 365 comes built in with a set of alerts, things like mass download of documents being detected. There are certain add-ons that you can bring in, things like the Cloud App Security product or Advanced Threat Protection, that will bring in more built-in detections. These all feed into this one alert center, where you can see security alerts that you should take a look at and review. If you click on any one of these, you'll get more details. I can see mass download detection today, when it was tripped, what user, and the fact that it's coming from the Cloud App Security product. But you can also set up custom alerting policies. So if I go, again, back to the classic view, I can set up a new alert test, and select severity, tell me something about the alert. But then once I do that, I have the option, I can set up a trigger-based alert on any of those audit events I was looking at before. So for example, if I've already set up the external sharing policy for my entire organization, I know nobody should be messing with that. If I see an audit log message that says an admin went and changed that, I want an alert immediately. That should never happen. We also have advanced capabilities so that you can set up threshold-based alerts or anomaly-based alerts as well. So you can kind of define when you, we'll take questions in just a sec. So you can also define when you want these alerts to come in. So finally, let's talk about, let's say you've detected something and you want to know what to do about it. A couple things here. First of all, one of the nice things about being in SharePoint or OneDrive in the online service is you get to leverage kind of the resources and information that we've provided. Matt, and I know Matt has been working on SharePoint security for over 10 years? Yeah. And his team, the Office 365 security team, we have a bunch of resources available for all the customers that are using this same service. The Office 365 security blog is a great resource for kind of upcoming and evolving industry threats, and if you see these things happening in your organization, what exact steps you should take. So all of that is available to you. We also have, you also have the ability to react or to be proactive in the case of threats. If you see a user, if you see evidence of a malicious user or user compromise, There's a bunch of different options available for you to kick out that user or block that user. Azure Active Directory has the ability to kick a user out from all M365 services. You can do this directly within Office 365. Even the individual workloads, there's a PowerShell command in SharePoint where you can instantly revoke a user's sessions. If you're using the Azure Identity Protection product, you can also set up things like proactive policy. If I see a user's session become risky, if I see one of my users using a password that is now known compromised in a public password dump or breach, I can automatically start blocking that user from accessing the service. And finally, in SharePoint and in OneDrive for Business in particular, we have some really, really great tools to help you get things back into a good state after an attack. If you're affected by something like ransomware, which can be extremely devastating to your business, in OneDrive, your users have self-service capability to roll their files back to a given point in time. There's even a great integration here with Windows Defender ATP, where if Defender detects ransomware on a given machine, it will prompt your user to say, hey, ransomware event has been detected. You should roll back and recover your files to before they were all encrypted, and it'll even suggest a point in time to roll back to before it saw the encryption events occur. So really, really good things start to happen once you start tying these different capabilities together. If you want to see that in action or in more detail, Mark Windle gave a talk the other day, but you can go find the recording online where you can sort of see that restore happening in real time. That's really cool. Finally, if you want to participate, finally Matt mentioned the importance of red teaming. There's a couple things here. The like advanced threat protection and advanced security products that you can add on to Office 365 have some ability for you to simulate attacks in your own organization. But we also have the, as Matt mentioned earlier, the bug bounty program. We have a rules of engagement online. If you want to participate, if you have security engineers or researchers working within your own organization and you want to exercise our security and report any findings, help make the service better for everybody, that's an awesome program to go take a look at. Okay, that was a lot of information in just an hour. This is security is an always evolving space. We're constantly making new investments here. The goal of all of this is we hope that you'll agree that SharePoint and OneDrive are the safest place for your data based on all the security investments we've made. And we're going to turn it over for any questions. Thank you, guys. All right.